Well, good morning or good afternoon, everyone, depending on where you are in the world. My name is Andre Rapp. I'm from Mindful Measurement, formerly ETS, currently also with Success Academy Charter Schools in New York City. I'm excited to welcome you to the NCME virtual session on artificial intelligence and educational measurement, trends, mindsets, and practices. What I'm going to do is I'm going to walk everyone through the basic structure of the session, talk a little bit about mindset for a few minutes, and then we're going to get right into it. A few logistical items. What I'm going to do is I'm going to pass the baton virtually, so to speak, to all of the other presenters throughout this session. While doing so, though, I will look at the chat window to see if anybody has a question that they would like to ask, and I'll throw in a question while we're doing the transition. So please, if you're listening to the presenters and you have something that you want to inquire about or a comment that you want to share, please put that in the chat window. We'll see, we'll do our best to get to that. All right, with that being said, let's get right into it. So here's the session. If you've seen the outline, this looks almost exactly the way it was in the, either in the submission, if you've seen this, or in the original program or some other way. Potentially. We have 4 presenters. We used to have a 5th presenter who unfortunately isn't able to be with us. So if you hear from Michael Udelson's presentation, unfortunately he cannot be here today. You can contact him via LinkedIn, and he was probably very welcome, very interested in sharing his thoughts with you, so please do that. But you can see here, I'm going to start the session off, and then we have 4 presenters and 2 quote-unquote discussion / conversational slots where we're going to reflect on what the presenters have shared with us. So I'm going to start off with a few higher level comments. The first one that I want to sort of throw out there is this idea of common desiderata or common goals in educational measurement or learning settings. So I think no matter where you work in the world, if you scan this list with your eyes for just a second, you probably see that several of these key components of assessment and learning systems are things that you and your organization, people often want. And as we know, many of these are really difficult to achieve at a high level of fidelity, reliability, validity. And so today what we're going to do is we're going to really look at this problem from the perspective of artificial intelligence and automation, and really think through how these processes interact with the resource constraints, the political and policy constraints, and the goals of the particular context of each of the different presenters' work environment, so to speak. I thought it might be nice to list a few examples of automation that we may be familiar with. So I know automation isn't necessarily the same as artificial intelligence, right? But so here I thought I started listing off some automation components that are relevant for construct relevant interpretation. So not just sort of pure machine QC kind of processes per se, but rather things that affect our interpretation. So you may have seen automated assembly of test forms, presentations of items, tasks, or forms for CAP MST. You may be familiar with automated presentation of didactic resources, so learning resources or activities. There's automated scoring of constructed responses holistically, analytically. We think about automated provision of diagnostic feedback, so error diagnosis for written responses, spoken responses, or interactive performances. We have seen maybe automated visualization of trends or characteristics through corpus analyses or those kinds of NLP-based tools. There's research into automated generations of questions, automated generations of text, automated text complexity measurement, automated item generation, conversational management. If you work with multimodal data, there are certain processes and features that you have to generate and then synthesize. That's automated. Detection of behaviors. Some people think about this. We'll hear about this today. So cheating, disengagement, notifications for teachers, alerting teachers to who needs attention. All of these are examples where behind the scenes we have some kind of algorithm doing some of the hard work for us so that we can outsource that to the machines when things are live. And so what I did with Carol when we were writing to our presenters and our colleagues, we said, well, here's some guiding questions for the session that we like you to think about. So some of these presenters that you'll hear from today, they may go into these questions maybe linearly. Some of them may just talk about some of these issues here. But I thought it might be good for everybody just to get a little bit of a stimulation here for the mindset that we wanted to engender. So one question that we had was, so how are our systems actually, quote unquote, intelligent? So if we call something artificial intelligence and we talk about automation, where is the intelligence? What do we mean by that really? For those of you who worked in this area for a long time, you know that humans and machines always interact. So in what ways do humans and machines interact or connect during the development and the deployment to create this kind of intelligence that we're talking about? Many colleagues that we've spoken to over the years, they have said that their ways of thinking about fundamental issues like reliability, validity, fairness, utility has changed through their work. So we wanted to sort of say, well, you know, can you talk a little bit about this? How has our work, your work shaped this way that you think about these issues? What trends are you most excited about? So it's 2020. You know, we are living in very challenging times, both technologically, emotionally, socially. You know, what trends are you most excited about? What are some common misconceptions around artificial intelligence in our use context that you think you want to correct or that you wish you could correct? You want to talk about that? How can people engage with you in this work? Or when if it's not you personally, maybe the people you work with or the community that you're a member of. And then finally, and I think this is of course really important, how has the COVID crisis changed the way you are approaching your work or are thinking about these issues? And I think even if you're a participant, you're just listening in, I think these are good questions in general to have whenever somebody tries to make the case for a particular implementation or solution for you, and you have to learn about that, or you're developing something, some tools, some methodology along the way. And I want to also quickly mention, and this is my last slide before we get into this, there's also, I think, this social question about automation and privilege. So, you know, we always talk about the digital delivery and how wonderful this can be, and now we're doing things remotely and that opens up opportunities. But we all also know as human beings, we have a lot of challenges with this. There's emotional challenges, there's psychological challenges, there's technological access challenges. And, you know, I can't help but think about these issues this year is one of these examples from the Pew Research Center. If you look at this, you know, on the one hand, I think in the public sphere, we talk a lot about how wonderful it is that broadband access, for example, is now pretty prevalent in the United States. But if you dig a little bit deeper, there is still big gaps between access to technology, internet resources. I mean, think about something as simple as if there's a laptop at home in a family, but, you know, multiple people in the family, the parents, the children may have to compete for access, for example. You know, and we have in a learning environment where we give people homework on a lot of like intelligent systems, digital systems, you know, are we disadvantaging these kinds of learner populations, for example? So I thought it would be good to put that in there as something to reflect on as we're listening to our different colleagues here who present us with their ideas. And so with that, I'm going to actually stop my quick introduction here, and I'm going to turn it over to Janice Gobert and to Mike Sao Pedro. I will close this off here by just saying if you have any questions, you'd like to see any slides afterwards, after the session, to have one contact point beyond watching this video on YouTube potentially, feel free to write me an email at this address here, drandre.rupp@gmail.com. And I'll do my best to put a zip folder together that I can send to all of you. All right, so let's get right to it. I'll stop sharing, and Janice and Mike, you're ready to go. Please introduce yourselves, where you are, who you work, and then let's go from there. Everybody will have about, you know, 13, 14-ish minutes to allow for a little bit of transition time. Thank you.
Hi, everyone. I'm Janice Gobert. I am a professor at Rutgers University, put my slides up. My co-author is Mike Sao Pedro, who's the CTO of Apprentice, which is a startup company that we founded together with Cameron Betts. And we are productizing Inkits and Ink Blotter through our company via SBIR grants and sales, etc. Thank you so much, Andre, for the invitation. It's really nice to be here and be here with all of you. I am going to stop my video, however, so that it doesn't look like I'm not looking at the screen because of where the camera is. Well, I guess actually you're going to see me not looking at the screen anyway. But all right, so I'm at Rutgers School of Education, and I'm the CEO of Apprentice. So I'd like to start with, let's see, I'd like to start with the problem that many of us are talking about, which is the US and many other countries face a STEM crisis. And so on our last international comparison, we were ranked 19th worldwide, and this is down from 2009 when we were 13th. So that's a significant drop. So state frameworks, including the Next Generation Science Standards, seek to improve students' science proficiencies. And these require that students learn competencies such as asking questions, developing and using models, planning and carrying out investigations, analyzing and interpreting data, which is a difficult one, using mathematics and computational thinking, which I'm sure many of you are interested in, constructing explanations, engaging in argument from evidence, and communicating findings. And so teachers also have to assess students' competencies at these practices. But imagine here's a classroom. All these kids are doing hands-on inquiry experiments, the way inquiry is often done. And each kid may be working on a completely different hypothesis or driving question or experiment. And I like to point out two types of kids. These are these are boys just because this graphic is so good for this. But here's a boy, Billy. Billy is a kid who is really into science. He can do all the practices that I told you about, but he's maybe not good at writing. If the teacher's relying on a lab report, this will be a false negative. That's a problem for this kid. It's frustrating. It's frustrating to the parents. And for a country that needs STEM workers, we're basically tossing this kid out on his ear. Here's another kid. This is John. John is a kid who's not even doing the experiment, and we actually have data that we show of kids like this. They're not even doing the experiment, they're catching the buzz. And so when they come to the claim evidence reasoning or writing up a lab report, they can actually generate scientifically accurate text, but they've in fact not even done the experiment. So this is a false positive. This is a problem for the teacher. This is a problem for assessment. And this kid will get pushed further and further along until he's going to hit a wall, right? So this is kind of the issue that teachers are dealing with. They're trying to assess students on the next generation science practices, often doing this kind of method for assessment, where they're walking around the room trying to assess students. So here are some others. So you have problems with typical assessments. You have multiple choice or fill in the blanks. These are easy to grade, but they're not authentic. You have high stakes summative tests that rely on multiple choice and open response items, where feedback is given too late to help students learn and kids struggle in silence. Then you have the hands-on labs, where students are often unable to complete them independently. They require equipment, material, setup time, space. This is particularly problematic during COVID. They're difficult to grade, difficult to keep consistent. And it's really not safe for kids to be doing chemistry experiments, for example, at home. And then you have lab reports that are often done in association with a hands-on lab that rely on open response. These are work products. They're hard to grade, and they actually don't capture inquiry competencies. In fact, I published a piece in US News and World Report, and we have analyzed data that shows that if teachers rely on what kids write, between 30 to 60% of the time, the writing does not reflect what the student knows. So that's very, very high. So our goal is we wanted to assess the science practices. We wanted to better support teachers in their daily instruction of science practices and in their assessment of science practices. We wanted to better support students in their learning of the science practices. And what we wanted to do was to create a rigorous, scalable, technology-based tools for teachers' assessment and instruction and for students' learning. So scalable is really the issue here that we're really interested in. This is how we're leveraging the AI from a design point of view and a computational point of view. And, you know, I would like to think that we're operationalizing things at a fine enough grain size that we're still capturing a lot of nuance. And that's a an issue that's a little bit contentious, I would say, amongst learning scientists and more traditional learning scientists and educators, for example, about how you operationalize these practices. That sounds too reductionistic. And I've had many arguments about this exact thing. So INKITS is Inquiry Intelligent Tutoring System. These are virtual simulation-based labs, over 100 of these, for formative assessment with patented automated scoring and student support. They operate in middle school and early high school, physical life and earth science, or grade 4 to 10. They measure content, practices, and cross-cutting concepts. There's no installation required, work on all browsers, etc. And they offer automatic, more rigorous, scalable approach to formative and summative assessment, personalized learning, including special education. So for students, what we have are authentic inquiry using these simulations, or what I call micro worlds, and they go through the practices identified as prescribed by the next generation science standards. They have Rex, who's jumping in real time when the system detects the students need it, so it's not on-demand help. And these are driven by our data mined algorithms. And then we have student reports, because students really like to see, especially gifted kids, how they're doing. Then we have scaffolding in real time using Rex. These are triggered by our EDM algorithms, as I said, when students need it. They're delivered by our cartoon dinosaur, and they provide students with multiple levels of support, including orienting, conceptual, procedural, and instrumental. For teachers, we have real-time reports for assessment, where you see here on the left, you have the dark blue, which suggests students are competent at the practice. You have the medium blue, which suggests they're developing competencies as they're working. And you have the yellow, which are students who are at risk. The teacher can drill down and look at the yellow here, where I'm pointing, and see who's at risk. So after we did this reporting infrastructure, we decided to develop an alerting dashboard. So this is called Ink Blotter, and you can see it here depicted on the iPhone on the right-hand side. And I'm going to drill down a little bit on that. So here's a close-up of Ink Blotter. So you see here what we're seeing as alerts as they happen. So here's one for John Marcone for hypothesizing. The teacher clicks on it. It says, John Marcone is struggling to understand what an independent variable is. So she sees what the student has done in this lab and the student's competencies today on these 3 practices, and then these alerts that she's gotten for John. So she can go over and have a conversation with John about what is an independent variable. So we've been analyzing, so let me just back up for 1 second. So this view here is in the as they happen. The teacher can also prioritize certain skills, or the teacher can say, okay, maybe I have a whole bunch of kids who are struggling on hypothesizing. I'm going to stop the class in real time. So she could switch to the class view here, class view, get a metric on how many kids are struggling, and decide and stop the class in real time. So this allows her to do one-on-one support. It allows her to do differentiated instruction with small groups, or it allows her to stop the class in real time. We have a paper actually in revision right now to Journal of Learning Analytics, where we used epistemic network analysis. And in fact, we were able to show that the help that teachers give predicts how well the student's going to do on their next opportunity to do the practice on which they were helped. So that's very cool, right? So we know that if teachers focus on the content, which many science teachers do because they don't quite get the practices, and they can't really bump up to that moderate level of specificity. If they focus on the content, they actually students don't get better, of course, on the next opportunity, because the next opportunity is going to be in a different content area. But if the teacher focuses on the practice and really articulates and has a conversation with the student about the practices, you can use that data to predict how well the student's going to do on their next opportunity. So that's really very exciting. Just as a note about COVID, we scaled to a whole bunch of, we're in 50 states now, and we actually have usage in 86 countries now. But during COVID, teachers used Ink Blotter synchronously with kids in video like this, like in Zoom. And we actually see some really nice data where students maintain or actually get better even during COVID. So that's really very exciting for us. We're continuing to analyze that data, and we just submitted a paper to AERA last week on some of those data. So this is Ink Blotter. Teachers absolutely love this. It changes the way they do instruction about NGSS, and our reports really change the way in which they grade, because the grading is essentially done for them, including their claim evidence reasoning statements using the NLP algorithms. So here's sort of an overall how the system works. So you have the student working in a virtual micro world. The system is working in real time, generating these reports and alerts. At the same time, the virtual tutor can be jumping in when the student needs help. And as I said, we have 3 patents now on this system. So now, how are our systems intelligent? So I want to drill down here on the notion of virtual simulations and how they can provide real-time assessment, scaffolding, and alerting potential. So they have the affordance of authenticity. They offer greater validity than multiple choice tests, but many systems are not used to assess the skills they're designed to foster. That's highly problematic, right? So when you have a system like this and it's instrumented the right way, it can generate rich, high fidelity log files. These are used for performance assessment. And our friend Andre tells us that work products and work inquiry processes can be used for assessment. And these can give immediate feedback, therefore blending learning and assessment so extra time is not used. And the kids can work at home as they did during COVID. So there's machine learning or educational data mined algorithms under the hood, and this is used for real-time assessment, scaffolding, and alerting. We use data mining and text replay tagging to develop canonical models of what it means to demonstrate a skill, and then in turn develop algorithms that can handle the variability of students' processes used in inquiry. And we've done this for all inquiry practices now with very high match to human scores, up to 95% match. And these algorithms were validated over multiple topics without retraining the machine learned models, and generalizability was tested on new students not used to build the model. And I'm going to pick up on that again in a minute. In what ways do humans and machines interact to connect during the development and deployment to create this intelligence? So I just—
Hey, Janice, sorry, I'm so sorry to interrupt you. When I see you go through these questions, we're getting a little bit short on time. So if you could wrap that up in the next 2 minutes, okay. And then maybe we can come back to that later if we have time at the end.
Sure, sure. So we use evidence-centered design. I'm sure many of you know about that. You know, we're looking at correlations to standardized assessments, but Sussman and Wilson point out that if you have a really rich intervention, it may not actually correlate highly or measure up in terms of factor analysis loadings to a summative assessment because they're getting at inherently different things. So I think what I'm going to do is stop there and give it to the next person.
Okay, fabulous. Thank you so much, Janice. And we probably have some time later to come back to the questions, but right now I appreciate that you give everybody a little bit of space so we can all share our time here. So the next team of people is Stephen Tang from eMetric and Piotr Mitros from ETS. So I don't know who of the two wants to start. I'll leave that up to you. But if you could please again introduce yourself briefly and then we'll move on. And I want to also say to everybody who's on the call, if you have any additional questions that you want me to throw out there while we're going through the different presentations, please feel free to put them in the chat window I'll monitor that, and I'll try to put in a question in between presentations as much as time permits. Thank you.
So I'll go first, and I'm trying to figure out how to take over the window, or you can just pin me and view my video. Can everybody do that?
No, I think, Janice, you might have to stop sharing and then click on the stop sharing.
Disable for sharing. There we go.
Ah, okay. Now it's you, Piotr. I see myself.
And sorry. So
nice recursion.
Yes, Zoom did something stupid when I tried to take over the screen. Okay, well, in either case, Steve and I will be talking about new data sources and modeling opportunities, which will sort of be a high-level, I'll start with a high-level overview, and then Stephen will jump into a few specific applications. So to give my background, I'm a senior research scientist at the Educational Testing Service. Pre-COVID, I was the director of a center called the Center for Next Generation Psychometrics and Data Science. We had a reorg, but what we will, and previously I was the author of the edX platform, so that's sort of what brought me into ETS. And the general path that we've been on with data so far is for about 3/4 of a century, we started working with response data. And response data, we have very nice, sophisticated mathematical models around, and it's really awesome. At some point, we noticed we had system logs, which I'm not giving dates here because this really varied discipline by discipline. Physics education research was decades ahead of psychometrics here. EdTech was a little bit ahead. So system logs kind of are just what systems spit out. They're pretty messy, but they sort of have applications for detecting things like obvious cheating or if students were satisficing. From there, we sort of moved on to trying to explicitly capture what we wanted. And this was sort of the era at which I stepped into the space. That's when I built edX. And we had structured formats, structured documented formats where we could tell what students were doing at every point in time in the system and extract meaningful information from that. And we sort of expected this to really revolutionize what we know about student learning. This was, I guess, 2011, 2012. And what we found was that we built out a nice research ecosystem. All of a sudden, we could, for the first time, really know how students were spending time in courses. A lot of really nice descriptive statistics, but it didn't lead to the sorts of cognitive insights that we had expected. And now we are on step 4, where, again, we have a lot of promise. We'll see if it pans out, but we're now moving from just being very exclusive about capturing everything that students do to sort of moving towards things like evidence-centered design, where we're explicitly trying to create activities that elicit and surface student thinking in the types of data that we collect. So the wonderful thing about this is that there's a ton of literature about how we do this. Teachers have been trying to elicit evidence from students for thousands of years, and we have really nice in-classroom assessment techniques, and the question is, how can we capture these in digital settings? We've started to build out technologies. This is a system from Jiangang Kao, who built this before I came into ETS, for assessment of collaborative learning. Students are working on a structured activity together. We have captures of videos of students. We have captures of chat logs. And this captures a lot of information about constructs like soft skills and how students interact. And that's kind of awesome. And right now we're trying to figure out how to make sense of that. And in contrast to previous kind of the edX example, we know that the data we're looking for is there. One system, there was a question about how we're adapting to COVID-19. One system I'm working on right now is building a dashboard for teachers during COVID-19 that allows teachers to see writing in real time. And again, this is a place where we know that this writing contains the constructs that we're looking for and a lot of constructs we couldn't previously measure. So again, that's a setting where we're trying to move from simply capturing evidence to designing, making sure that what we're capturing contains the evidence we're looking for and how to make sense of that. A third place that we're trying to do this is in designing activities that align to traditional cognitive trajectories. generally, we sort of look at learning as, kind of students are first exposed concepts, they move into the student zone of proximal development, then go through surface, deep, and transfer learning. And as students do this, teachers want to know where along the way students are. And we're starting to design activities where as students are solving problems, we provide inline scaffolds. So with scaffolds, students usually can see what scaffolds they use for how long. And the goal is to really be able to position specific constructs along these types of trajectories. So that's sort of, we've sort of been down this windy path. Now we're eliciting that data. And as we're doing that, we now run into challenges. So one of the challenges, I apologize, I'm covering some of this up, technology. How do we handle terabytes of data in real time to deliver this to teachers? Psychometrics. As it turns out, the kind of, one of the questions was around psychometric quality metrics. Psychometric quality metrics, our reliability, validity, fairness, utility, are defined in very different ways from the way that equivalent ones are defined in machine learning. And there are good reasons for that. They come from both education versus non-education fields and big data versus small data, and figuring out how to bridge that. There are human issues. Most people in the community that I now operate in don't necessarily have background. Well, there aren't actually many people who have background in both psychometrics and machine learning. There are organizational issues. How do we get the data that we need? That's really the greatest bit of strength comes from integration. When we have data from multiple systems designed to elicit student thinking, and so on and so forth. So what's been really nice is as we've been going down this path, we're starting to surface some of these issues and address them head on. And how do we engage? I would encourage any of you who are interested in any of this work to reach out to me. I'm very interested in engaging. And now over to Stephen to talk about some applications.
All right, great. So I'm going to go ahead and share my screen now. So
that's fabulous. And just to give you guys a little heads up, so this was about 6 minutes. So Stephen, I would say you probably have about 8 or so minutes, roughly around there.
That sounds perfect. All right. So, okay.
And don't forget to introduce yourself too, please.
Yeah. So I should be sharing my screen now. So hopefully you see that. So perfect. Yeah, so hi guys, I'm Stephen Tang. I'm the Chief Research Scientist at eMetric. eMetric's an assessment technology company. And so I'm just gonna go ahead and continue on our discussion. And to give a quick outline, I'm gonna basically talk about 2 main points. I'm gonna first talk about sort of AI methodologies, right? Supervised versus unsupervised methods. And then I'm just going to talk about a few examples of some of my recent work where we're trying to apply AI to assessment data analytics and essay scoring. So I wanted to just give a quick overview of AI methodology. So why is AI such a hot topic over the past few years? Artificial intelligence, we've heard that terminology for decades and decades. What's with the resurgence? So in my opinion, a lot of the resurgence comes from, hopefully my internet is working. A lot of the resurgence comes from sort of new AI techniques. So what are these techniques? These are sort of the new statistical methods that have just worked really well over the past few years. So when we talk about supervised techniques, we mean, you have labeled data, you have examples, you can just tell the AI model, are you right or are you wrong, and continue to improve the model that way. And for me, the 2 main techniques that I work with and a lot of other people have found success with are decision trees, and particular sort of ensemble gradient boosted decision trees, as well as deep learning and neural networks. So these are sort of, in my opinion, the AI methods that sort of caused, they found a lot of success in recent years, and that's why AI is in the news. So I'm trying to think about AI from like these methods point of view. And we also have unsupervised techniques, right? You don't have labels in your data. You just want to sort of figure, information about the data. So for me, the techniques I've been working with is mainly just clustering. And one way when we think about intelligence, why do we call it artificial intelligence? Well, one way to think about it is that these methods actually do a lot of the feature engineering. They sort of figure out what's, going on with your data for you, rather than sort of the other approach where, you have human intuitions, you have, preformed hypotheses. So that's just one way to think about artificial intelligence. So some applications that I've been working on. So for supervised applications, we have essay and short answer scoring. We also want to predict, student dropout and other outcomes. And sort of more recently with COVID, we have kind of this, maybe a surge in remote proctoring. So you sort of have image analysis to kind of constantly look at, what's going on in students' images. And then we also can mimic student behaviors for software testing. And then some unsupervised applications are, you want student behavior categorization, mainly through the clickstream data that you can collect during test taking, as well as clustering and grouping school performance and clustering and grouping student performance. And sort of, I guess, when I think about AI, like the terms kind of had a resurgence, it's really because data has become much more plentiful, right? So AI is made possible by careful attention to curating high quality and large quantities of data. So that's sort of, when we think about AI, there's a bit of methods, right? What models are you using? But it's also sort of this new era of just everyone's paying attention to collecting a lot more data. So this can be even just at like the very granular, click stream, what are my users doing click by click, or at a broader level, state level education departments are just collecting much more data to work with. So I want to just jump into some clustering work I've been doing. So I have a quick demo to show. So here we've, from the state of Nevada, they sort of have all this public school level data. We have discipline, enrollment, financial, just a whole bunch of information about schools. So what we've done is we've created sort of this, AI application that does clustering on that data, right? So, as I talk about, just stakeholders are just gathering more and more data. Well, we want to kind of apply AI to have a kind of a new way to look at the data, right? So every circle you see here is an individual school, right? And there's just like, this is just a new way to kind of figure out what's going on with your data, and, just doing some multivariate analysis using clustering on the cloud with a visualization. So, and then I guess I just also want to show one other kind of AI application I've been working on. It's kind of, we're building decision trees for the user instantaneously. So, we want to maybe like look at how can I, predict my ELA score for my high schools using all of this data that we've been collecting. So we can just kind of quickly run an AI model on the cloud for the user. I imagine researchers or, just kind of advanced stakeholders can really just dig into their data and kind of figure out, okay, it turns out percentage students transient is, a major signal in this particular model. Can we follow that up with additional analyses? So that's sort of the work I've been doing, trying to bring kind of these AI methodologies to users via the cloud. And I guess the last topic I wanted to touch on was just kind of trends in, natural language processing. With the advent of deep learning, we've had kind of a new way to understanding language. This is sort of one of the hottest areas in AI in the past couple of years. And so what I'm seeing here is we take these new methodologies, right, leveraging deep learning, and we can just build systems on top of that. And the reason why we might prefer deep learning is they sort of look at language in kind of a new way. They get at context, they get at just a lot of features that I guess traditional NLP methods haven't been able to do. So this is just a really hot area that I just kind of wanted to highlight. And then sort of, running low on time, the last thing I want to leave us with is, advances in AI and machine learning are going to continue to lead to new approaches and exciting solutions for our familiar measurement problems. And I think there's just, just a whole lot with just kind of thinking about the new way AI can influence where we're going next. So with that, there's my contact information. Send me an email. And I think I'm done now. So I will go ahead and stop sharing and turn it back to you, Andre.
Yeah, that's fabulous. In fact, thanks so much. We'll turn this right over to Neil. Neil, so if you're ready, you can try sharing your screen and then introduce yourself. I was just checking with the NCME staff to see whether anybody had written a chat comment. I don't see any. I have lots of questions for the presenters, but I'll hold those for a little bit later then at the moment if no one else has one, and give everybody the time and the floor. All right, Neil, let's go. Please introduce yourself, and you have about 14-ish minutes or so, like everybody.
Gotcha. And I think I'm sharing the thing with my presentation mode, right? Is that you see these two slides?
Yeah, you do. Janice, you resolved that earlier. Let's take quickly 30 seconds. How did you change that again?
I'm seeing your notes, Neil.
Yeah.
Yeah, you just swap displays, swap screens at the top usually. Swap displays.
All right, excellent. Thank you.
Yeah, take your time. It's okay. We'll take 30 seconds here. We have that. If that's easy. If not, we can go through this. But
I am going to bail out on you watching me learn how to use PowerPoint and screen sharing. And let me instead do this. And Andre, thank you for putting this together. And since you actually asked 6 questions, I'm going to answer them, and then I'm actually going to say more. I'm going to actually say.
Yeah. Thanks should also go to Carol. I will say this, everybody. So Carol and I have done this together. So
thank you,
to her
Carol.
as well. Yes, absolutely. Yeah, thank you. Let's go ahead.
Excellent. So anyways, I am actually Neil Efron. I'm a professor at Worcester Polytechnic Institute, and I teach AI. I've been doing that for a long time, and I do a lot of data mining projects. In fact, I've run 2 longitudinal competitions where people could use our data sets. But I also love running randomized control trials to try to figure out what works. And so rather than going into my standard spiel of what is it that I care about, let me Andre and Carol said, can you answer these questions? How are our systems intelligent? To what degree do humans and computers interact? I love that question, okay? Because that is right up my alley. And if you don't walk away thinking, hey, there's something different about it, the way Neil talks about machine learning and humans in the loop, then I will have failed as a good speaker to taught you something important. How has our work been shaped by fundamental methodological principles? I'm going to say I generally don't care about most things that NCME members care about. And so I will be provocative in that way. What trends do we see? That's a good one. What are the common misconceptions about AI? And that kind of relates to how I think about our intelligence. And how can members engage with us? I'm super excited about that question. And there's several projects that we have that are taking in external researchers and running their ideas. And so it's a great question. So let me go through them. How are our systems intelligent? So even though I teach artificial intelligence, I don't believe in artificial intelligence. I believe in teacher intelligence. And I basically run a simple, dumb platform that has features that teachers like. And I first built that. We have some natural language processing projects that are kind of cool, but to be brutally honest, we're just taking standard NLP stuff off the shelf and applying them. And I'll show you how we do that in what we call this project run by Anthony Vitello, where we're doing this natural language processing. 2, in what ways do humans and machines interact? And so, as I said, I believe in teacher intelligence. So you're going to see, I have a bunch of projects right now that almost all of them involve, we pay teachers to do things, and then we try to machine learn what is it that the teachers are doing. And so I don't really believe that we build intelligent tutoring systems where kids sit down at the computer and and then they go. Anyways, question 3, and how has your work shaped the way we think about fundamental methodological principles? So I meant to rile up the audience a little bit. I don't come to NCME often because this group tends to be obsessed with things where you have small tests and then they always get asked questions about what is the reliability and validity of every question inside of systems. there's 100,000 questions inside assessments. We take questions from books. And so, anyway, so there seems to be a fundamental disconnect with actually sometimes the traditional NCME things. Like, you know, we love diff analysis, right? We should make sure our questions are not biased actually towards people. In fact, I'm super proud of actually my team that has actually done this really cool work using machine learning that actually, and particularly word embeddings, that actually that can actually have horrendous biases. There's this wonderful paper by actually that has Adam Kalai on it. Man is to computer programmer as woman is to housewife, is what you get out of actually these word embeddings. And so how do you actually use these fancy AI techniques and yet actually not actually screw kids over and be biased? It seems wicked important to me. Like that seems, that when I think about fairness, that's what I think about. Anyways, we're working on that. I'm actually proud of the fact that we basically fail to actually detect a bias in our grading system, even though we're using these things that have actually historically actually been shown to actually be disasters potentially. So what trends in our work are we actually most excited about? Well, this is the graph of actually COVID times. We normally have about 300 teachers make an account, as you saw in like February, and actually in March and April, we're like 6,000 and 7,000. So things are going insane right now. We have 300,000 kids now that are actually using assessments, 500 million actions logged. And most of them are doing some very simple stuff, but I'm actually working hard to try to figure out what is the next set of technologies we can do to actually help actually get these teachers to be able to actually keep their kids engaged. And so feel free to ask me about that. I'm actually writing an ERR grant right now about actually connecting using Zoom APIs and assessments data so teachers can actually pay attention to what their kids are doing and see them in Zoom, kind of like the way I can see you guys in Zoom. But of course, most of you don't have your cameras on, and that's not the way actually a 7th grade math teacher should be running her class or his class. All right, what are some common misconceptions around AI actually in the use of our context? So there's plenty of systems, including Carnegie Learning's Mathia or McGraw-Hill's Alex, where actually, you know, they believe that actually if a child learns something, let's let them move on and do the next thing. Why would you possibly hold them back? And I'm here to say, yeah, I hold kids back. What we really want to do is we want to keep teachers in the loop. Why? You go into some of these classrooms that are using some of these self-paced systems, and some kids are in chapter 2, some kids are in chapter 23, and the teacher just taught chapter 11. And in fact, often no one is actually working on problems in chapter 11, right? And so if you let the technology take over, you get this sort of stuff where it's so easy to blame kids when they actually don't do their work. When in fact, us platform providers need to actually take responsibility to actually design systems that give teachers strong roles. So how can members engage in our effort? I have 2 sites to actually tell you about. So there's eTrials. So the Schmidt Foundation gave me a bunch of money to actually help external researchers run studies. And so we have a dozen researchers right now running studies. In fact, one I was just talking about that might be actually key to this audience, actually Andrew Butler, a really good actually cognitive psychologist and guy at Washington University in St. Louis, who's done work on the role of multiple choice versus non-multiple choice, traditional sort of NCME type issue. And we want to actually run a study. Typically NCME issues are like, hey, is multiple choice better for actually assessment? I don't really care about that. I care about, is multiple choice better for learning? Because most of the problems children do, and a 7th grader will do about 3,000 problems if they do their homework every night. The number of items on any state test will be really small relative to that. So, anyways, you can come to eTrials and actually go propose a study. There's also a cool opportunity that Schmidt Futures is actually doing right now called the Futures of Learning Tool Competition. And so you can get up to $250,000 to actually partner with a platform provider. Anyways, those are the answers to my standard questions. And I put myself a timer because I actually only have 4 minutes left total. But what the hell is assessments? So
yeah, you actually, just let me interrupt you. Just take a deep breath. You actually, I think you have more like 8 minutes. So you,
I have 8 minutes.
I know there's 177 slides. I think I saw coming.
Okay.
But no, you're gonna be good. But you have 8 minutes, and it's all good.
All right, then I'll take a deep breath. Thank you, Andre.
Yeah.
I actually want to tell you that actually everything going on in assessments it's a husband and wife deal. So Christina Heffernan and I, she's at the other end of the house. She's the executive director of the Assistance Foundation, and she's like laser focused on what is the roles to actually keep teachers actually strongly involved as we actually build out these kind of interventions. And so I told you, what is Assessments? It's a platform that teachers use. They build their own content. They can write their own problems, or they draw problems from libraries that already exist. Students get instructional assistance, while teachers get assessments. Okay, that's the name, Assessments. So if you were to go to assessments.org, you will see frequent, really highlighted illustrative mathematics, open up resources, Engage New York, these guys right here. And if you were to actually go in there, you would actually be able to find actually these resources. There's also a set of what we call skill builders that actually give practice until kids get 3 right in a row. These are the 2 main sort of bread and butter things we actually do. Let me actually just quickly show you actually what that looks. I made actually a tiny movie that you can kind of see what happens actually when a teacher comes here. They come to the site, they click on illustrative mathematics, they realize I'm 7th grade, they realize I'm doing actually unit 2, they actually say I want to do the practice problems, they figure out they're in lesson 2, they actually see all the problems actually, because since these are released under Creative Commons, they're picking, oh, I want this problem, I want this problem. This is what you all had 7th grade math teachers doing, right? They pick problems and say, you know, do stuff. Here we actually decided to assign through Google Classroom, not through actually Canvas, but we've done like the API sorts of stuff here. And now when the teacher hits view, they go, now you're about to see Google Classroom. That's the most commonly used learner management system in America because Google gives it all away for free. And if a teacher, so now we're still inside Google Classroom, we're not at assessments, the teacher clicks and says on that assignment, here, they can see that actually only the 1 kid in the class named Christina Heffernan actually is in the class, and she hasn't done any of her homework because I assigned it 2 seconds ago. Here I'm giving you a little, you know, perspective of actually what is it that a kid does. The kid typed in some answer to an open-ended question, and I just typed in some garbage. And they might actually ask for hints. And in this case, actually, I said, give me all the hints. A teacher was supposed to be able to see actually that child actually needed to get told the answer. Type in 4. Anyways, that gives you a general sense of what assessments is. Next thing I want to show you is actually we have a builder, because like this is non-standard. Gobs of people actually tend to think, oh, teachers shouldn't be writing questions, right? Oh, us professionals that know how to do this should actually be writing questions. No, we give a builder so teachers can type in, you know, what's 2 + 3? What is the answer? 5. They could actually write a hint, count on your fingers. You'll see there are like 7 or 8 question types we actually over on the side. This happens to be a numbered type. Of course, we actually have ones like actually, you know, what are the causes of slavery? That's going to be an open-ended question. The system will not know anything actually intelligent to say about that. And you can see my crappy actually typing, as I don't even know how to spell the word the and causes of slavery. We also have ones that actually, of course, are more algebraically actually related. But I'm going to actually skip out of the builder to just kind of say the builder is cool. But what's really important to me as a teacher is we need actually teachers to be able to actually display in front of their class. And we have teachers now not displaying in front of their class, but actually making little videos saying, kids, I see, in this case, only 65% of you got this right. And if you were to squint, you'd realize, and I'm going to actually go to the next slide that will show you, the teacher is able to see 80% of you who got this wrong said 1. Okay. Now, if you look at this math question at all, you might be quick enough to be able to realize this is an order of operations problem, right? They added the 7, the 4 plus 7, the 4 plus 3, and then subtracted, but that's not right. Right. And so this little component actually, I think is super important in my world, that is actually putting the teachers actually in charge. And now here, if every kid is doing a different problem, you can't even have this conversation. And so I get excited about that. I think I'm going to skip to the standard. I'm not going to skip the one thing that I think is super important, which is.
Yeah, Neil, and let's make that the last thing that you're not going to skip. Let's make that the last thing so we can go to the next person. That would be great. Thank you so much.
All right, then I will actually, I will say, and I will stop sharing my screen and let the next person come up to just say the thing that I think is wicked important for us as a field to do is make sure that we actually are analyzing whether our systems actually close achievement gaps or exacerbate them. All right, I'm done.
Fabulous. Thank you so much. All right. Next, we have Colin Lynch. So Colin, let's see whether do you have anything to share that you want to try out, or are you just going to talk? We want to make sure that we can all see your screen.
I'll share my slides. Let me get into that. So,
okay, great. So now, while you're fiddling with that, let me just say, so if you also took another 14 minutes and Alina took 14 minutes, that only gives Carol like 2 or 3 minutes at the end. So I don't know whether that makes her feel happy or not so happy, but maybe we can keep it to, let's try maybe 12 or 13, if that's okay, Colin. Don't want to negatively disadvantage you, but if that's okay with you, I'll start there and then we'll see whether you need a little bit of extra time. Thank you.
All right, sure. My name is Colin Lynch. Can everyone see my slides?
Yes, wonderful. Thank you.
Wonderful. Okay, great. So my name is Colin F. Lynch. I'm an assistant professor of computer science at North Carolina State University. I also direct the ARG lab and am involved with the Center for Educational Informatics, which is a research center devoted to intelligent tutoring, intelligent learning environments, automated analysis, automated evaluation, et cetera, et cetera, et cetera. Basically, ways to transform education with information and technology. So I didn't structure, unlike Neil, I didn't put the questions front and center. I'm going to try to touch on them as we go. But I'll start with the last one, which is to say, if you're interested in being involved, email me. You can contact me through NC State, and I realize I forgot to put my email in the slides, but a lot of the work I do is collaborative work. I'm always interested in that, but there's also a lot of work I do through research groups such as the International Educational Data Mining Society, so IEDMS, and that society and that research area covers a lot of work of use of data in education and building models for how students behave, understanding student learning, and also things like adaptive testing and learning. So to go on, let me start with a bit of an idea of where I come from. So let me talk about my research trajectory, and that'll hopefully give you an idea of what I mean when I'm talking about AI in learning and in measurement. So this is where I started. I started my research career really with classical intelligent tutoring systems, specifically the Andes Physics Workbench. So to give you a brief idea of what this means, Andes is a classical model tracing tutoring system. It's an intelligent homework helper. Students use the system, they get a physics problem, they define features like vectors and bodies of mass, they create variables, they write equations, and the system helps them by doing things like coloring things red if they're wrong, green if they're correct, and so on and so forth. And a big part of my job was building this automated guidance that would use a model of physics to give students help and tell them what they need to do. So that's classical learning environments. And a key feature, of course, of that learning environment is it's contained, right? It's a single clearly defined task. Students sign in, just do physics, sign out, that's all we looked at, all right? My more current work is looking at this. I mean, the reality of today is that students, particularly at the undergraduate level, are not just doing one thing. Most modern courses are blended courses, and so students are getting their materials through an online learning management system. They are going to office hours in an online forum. They are sending questions to the TAs and to other students in an online forum. And they're using shared, in computer science, particularly shared development tools like GitHub, which allow them to collaborate with one another, make submissions, get results of automatic test cases and other features, which tell them how they're doing, whether their code is correct, and so on and so forth. And so instead of having a self-contained activity, if we want to understand how students are learning, we have to scale up to a much bigger picture, a picture that lets us see really their entire spectrum of learning processes, so we can understand the things they do in the context of their work. And so this gets at actually one of the first two, really the first two questions. How are these systems intelligent? Well, to go back for a moment to Andy's, this system was intelligent because we built a model, a rule-based model of physics that said how you do everything. And we applied classical symbol-based artificial intelligence to traverse through the model and figure out what students should do next and give them guidance on that front. And so its intelligence was in the algorithm. The interaction between the student and the system was very much students sitting down for a well-defined task, getting feedback from the system, responding, and moving on. In the more modern stuff that we're doing, where we're trying to analyze the collective research, to the extent the system's intelligent, it's really intelligent in the analysis. What we're doing with this work is we're trying to understand, as I said, the full picture of students' learning. And by collecting data that integrates across everything the students are doing, we can develop a much more coherent picture of how students are processing the domain, how they're dealing with it, and what their problem-solving process is. So if we go back to that, we can, for example, look on the online forums and see what kinds of things students are asking for. Basically, we can understand their help seeking. We can also look and see how they communicate with the teaching assistants and with the faculty. We can say, are they writing clear, well-articulated questions? Are they stating what their problems are, or are they just sort of floundering about? And just to cut to the chase, this large chunk of the pie is, in case you can't see it, labeled insufficient, right? So most of the time, the students are communicating with the instructors. They're not communicating clearly, right? Similarly, we can look at students' study habits. And one of our more interesting features here is we can look at everything they do, all their online activities, office hour visits, study groups, everything, to develop a picture of when students actually work on class materials and when they do not. Now, obviously, we miss some things like sitting outside quietly reading a book, but who does that anyway these days? So we can develop an understanding of when they work and how they work. And just to give you a brief summary of this, in general, of course, people would assume that bad students cram before an exam and good students are probably doing better and working earlier. In fact, as we found, everybody's cramming before every deadline. I know this figure's a little hard to see, but what we discovered is that the baseline activity is higher for good students, right? So we have an idea that in terms of study habits, it's not that the good students don't cram. They do. Everybody crams. But we can understand that bad students are simply doing less and dropping off earlier than the good students, right? And then finally, we can look at who students communicate with. When students work with their peers, and peer interaction is a major focus of learning, we can look and say, well, who are you getting help from? And we can discover that students who are doing very well in a class tend to be talking to students who are doing very well in a class. Students who are failing a class tend to get advice from people who are also failing a class, right? And so what this work allows us to do is, as I said, develop a bigger picture of learning, not just learning in terms of answering questions, but learning as a process. And then look for places where we can assess behavior and intervene in that, all right? And I should say, if any of what I cover, if you have a question about it, just feel free to post in the chat so we can make this a tad more interactive. So this trajectory, which really illustrates what's happened in AI and education more generally, not just in my work, is a shift from isolated systems to integrated platforms. There's been a greater movement from things like Andy's to things like what I'm doing, or things like assistance, right? Where assistance is a platform that lets people provide a range of questions and collect a range of information. Integrating data across things like assessments, GitHub, and other things allows us to assess students in a more detailed way. It's also a movement from specific tasks to learning processes, right? As we've come to understand more about how students learning, we're trying to develop a better picture of the totality of the process. Which also means we're moving into general platforms, right? Moodle, which I showed you there on the prior slide, actually just go back to it, right? 3 of these platforms are education specific, but GitHub Education is really just GitHub. It's really an industrial platform that is marketed for use in education. It doesn't include any tutoring aspects. It wasn't designed to teach anything, but it is a tool that the students use. And by monitoring how they use the tool, which is essential for the class, we can come to better understand how they're doing in the class. All right. And then finally, this is also a turn towards always-on monitoring and what amounts to continuous evaluation, right? If I am tracking everything a student does in a class, I am always monitoring them on one level or another, which means that I have the prospect to continually evaluate them. Now, our work is not focused on grading. I am not assigning students a course grade based on whether they study frequently or not. What I am interested in doing is evaluating how they are studying in the class, how they're working in the class, and trying to identify who needs assistance, who needs extra help, who should the teacher pull out, or who should be prompted maybe by an automated system, you know, why don't you go to office hours? You seem to be having trouble articulating your question. Why don't you talk to the TA? Why don't you post a message? Or why don't you look at this other related message, right? Okay. So in a sense, we're starting to head towards 1958, or what the future of education was supposed to be in 1958. Yes?
Yeah, Colin, sorry to interrupt you. I just want to let you know you have about 3 to 4 more minutes because I see it's slide 7 out of 26, so you might want to choose maybe a few of those, if that's a real number.
I'll pick up the pace. So we're heading to the future of 1958, where we're getting better at an integrated online, always monitoring education. I don't know about the flying helicopter chair, but you get the idea. So this gives us a lot of good opportunities. We can do early and continuous evaluation. We can track learning processes. We can grade things like grit, other persistent features of the students, assess teamwork, you know, problem-solving processes, future performance. That's all very good. So what could possibly go wrong, right? And I picked this with a mind to an assessment crowd, but you get the idea, right? Our ability to monitor students, to make models, to track them also mean we have the ability to affect their lives with our analysis and with AI, right? And so the A-level example is, although it's not really considered an AI system, what you have here is exactly this: real educational performance being evaluated by AI and in fact downgrading students' scores in a way that really affects their future, right? Which raises a number of policy issues that I will trip through very quickly. So the first is obvious question of fairness, right? If we go back to the A-levels example, more than 1/3 of the students in England were downgraded from the mark issued by their teachers, right? 1/3 of students saw their grades cut down, and not cut down based on a test, but cut down from what their teacher assigned them. The teacher who's been guiding them, supporting them, helping them all year long, the one who knows them best, right? Whereas private school students got double the performance of everybody else, right? And so in general, from fairness, people say, well, obviously something has gone wrong. And people, on the other hand, it's robust and dependable, right? And because, in fact, more students have accepted to degree courses. So this raises exactly the challenge. As we start building these models, we bump up against a fundamental societal idea of fairness. What does it mean for this to be fair or unfair, right? And so for many people, fairness means freedom from bias, but bias is inherent in AI and machine learning, right? There's obviously the bias by the designer. When I build a model, I decide what goes in it. But there's also bias from past data. If I'm predicting students' performance, I'm using what other students did before them, which means I am, in a sense, inherently biased against outliers. Or maybe I should bias in favor of them, right? But either way, that is a challenge with the AI because I have to decide how to use this. We also have more persistent and sometimes pernicious biases, like the inductive bias in the hypothesis space. How we build these systems has a real effect on student performance. And finally, there's the question of fairness as procedural regularity, or perhaps normative regularity. How do we decide whether what we're doing fits what needs to be done? I don't have time to go into what that really entails, but to get to the other issues very quickly, accountability. So
you have about 1 minute, Colin, and
right.
I need to cut you off.
Okay, 1 minute. I'll be quick. Accountability. Well, in the test case, right, you know who to go to. This guy, apparently, if you're in Scotland, right? But how do we go to something if we're dealing with a system like Summit Learning or even mine, where it's a lot of models, a lot of different AIs interacting, giving different guidance? Who do you blame when you do badly on the end of your test? That's a major open question. Another question, transparency, right? If I show you this model, not being a machine learning person, and I tell you it's a rule-based model, you can kind of get it, right? Predicting the major, looking at the major, are you a CS major, social studies major, what's your GPA, et cetera, here's the course you should take. How do we do it with this, right? These are, you know, support vector machines, long short-term memory networks. How do you, as a teacher or as a student, or worse yet, as a parent or their lawyers, understand how this is working and whether or not it is working right? All right. I don't have time to go into this, but I can talk about it offline if anyone's curious. And so the last question, of course, privacy. Always on monitoring means always on monitoring. So this is an example of a dashboard from Central China Normal University that shows some very interesting factors. You can track, just looking at the LMS, when students study, what they study, how they perform, or even where they are in town. And I'm not picking on CCNU for this. In fact, all of the data they used in building this is the same kind of data I can get out of the learning management system at my university, and most people can get. It's just when students access things, where are they accessing them from? And that is captured in standard web logs. So if we realize what it means with always on monitoring, we're really in a position to track whether you're studying from on campus or home or your favorite bar or whatever. And that raises fundamental questions of privacy that need to be discussed. All right.
And on that one, I'm going to cut you off right there. So,
all right.
Because we have 2 more people and I want to give them, Carol needs a little bit of time at the end. So thank you so much. So many ideas bursting out of the seams. I love it. Alina, you are next. You are our first discussion conversation leader. And then Carol, I'll do my very best to give you a few minutes. So Alina, if you have maybe 10 minutes or so of comments, and Carol can get a few more minutes, that would be lovely. If not, then she has a few minutes left. Thank you so much.
Thank you very much, Andre and Carol. Thank you for inviting me. I'm assuming you all can see my slides right now, correct?
We can, thank you.
Perfect, thank you.
Yes,
I don't think I will do my best not to use all the time so that Carol has a bit more, but feel free to stop me. Who am I? Well, my name is Alina von Davier, and I've been working in education for a very long time. I'm moving from ETS to ACT, and now I'm at Duolingo. I introduced the concept of computational psychometrics to emphasize the combination of machine learning tools with within a psychometric framework. And until 2 weeks ago, I was on the side of the testing industries, coming from a psychometric environment, trying to bring in the machine learning new aspects that I think are valuable. But now I change sides, so I am on the educational technology side, trying to cheer for psychometrics and bring psychometrics in. So wish me luck on that. I hope it will be smoother than it was before, but we will see as we continue to collaborate in this new, in these forums like NCME. So thank you, Andre and Carol, for inviting me. This is not quite a discussion because I have not had access to all the presentation ahead of time, but it's a way of approaching the questions from what I thought was perhaps a higher level perspective on what are we talking about when we are talking about artificial intelligence and machine learning, and especially how it is different from psychometrics. So again, this is not new. Definitely Stephen Tang made that clear in his presentation, that the data is at the crux of everything. is the new oil. And actually what makes a difference between our traditional work in psychometrics and that was presented traditionally at NCME, and machine learning and data mining is really the size and the type of the data that we need to model. But if we step back and we think, what's the purpose of this data and why are we dealing with it? And what does even intelligence mean? And what does it mean knowledge discovery and learning in general? If we look at what knowledge, how knowledge changed in the history, has been from evolution by capturing everything in our DNAs, moving to experience, how people experience, and eventually then moving into culture. So writing those experiences down in stories or having an oral culture and preserving all of that knowledge into the stories that we tell to children. And this really has been around for, well, since forever. But in the last century, we started having computers, and that brought us to a different way of generating new knowledge. And I think this is important for discussing what intelligence is and what do we mean when we talk about artificial intelligence. Anyway, what we know for sure is that as we went from capturing information and knowledge in evolution through our DNAs, moving to experience, then to culture, and now to computers, everything becomes faster, richer, and definitely bigger. So how do computers actually generate knowledge? Well, they do it in multiple ways, but one way is they fill in the gaps in the knowledge that we have, like a researcher may do. They also may emulate the brain. They do like reverse engineering with, this is a lot used in ITS, intelligent tutoring systems, or in other active learning environments. Or they might emulate the evolution, and here we are talking about a genetic algorithm. Or sometimes they systematically reduce uncertainties by assigning probabilities, which tend to evolve. Think about dynamic Bayesian networks here. Or they notice similarities among experiences and they reason by analogy. Think about nearest neighbor in this case. So what is actually machine learning? It did start in the 50s probably and 60s in artificial intelligence. So the purpose was actually to automate the automation. And this still is the case, and this is what separates it from other set of tools that we have there. So getting the computers to actually program themselves is a goal in artificial intelligence. And it also started in the 60s with algorithms, really smart algorithms, including neural networks, by the way. They've been invented many, many, many years ago, but they were not as successful as they are now because the data was not there. At that time, the algorithms were wonderful. The math was actually probably even better than what we have now, but the data available for running those algorithms was at that time very small. However, nowadays, we do have big data available due to technology. So this combination that is between algorithm and really big data, this is what made the click in the past few years. And we see this amazing speed from OpenAI and from other clusters of bright minds working on the right type of questions, creating a really breakthrough results. So let's talk a bit about how we can compare traditional psychometrics with what we see in machine learning. So in traditional psychometrics, we had a data set. And then we had a model that the researcher themselves or somebody else, the programmer, coded the model. So there is, of course, a bit of a difference, as any of you who ever wrote a computer code for a statistical model, you know that you need to code it slightly differently. You need to take care of, impossible occurrences, and you need to take care of some approximations there. But nevertheless, you have the data and the coded model. You use the computer to estimate those, and you have an output. Well, the full philosophy behind machine learning is that actually In this case, you would have big data. And you give the computer the output. You give the computer an example of what's the right response, what's a good essay, what's a good essay to score, what's a good essay to generate, to create, what's a good type of Shakespearean writing to create. And then the computer's output in this case is what's the right model. And again, Stephen had that in his slide where he said, artificial intelligence is the process by which the machine selects what's important. Now, of course, we can disagree with that. Nevertheless, it doesn't change the situation. So again, how do computers generate that knowledge? And I recommend you all this book by Domingos. I also took his Coursera course many years ago on machine learning. And what I like about the book and the course is that he's actually talking about the philosophical aspects of machine learning. So again, it fills in the gaps in knowledge, it emulates the brain, emulates the evolution, reduces uncertainty, and notices similarities among experiences, which Domingos put together into 5 tribes of machine learning. He categorized those into symbolist, connectionist, evolutionary, Bayesian, and analogizer. I guess that's the right pronunciation. So what that means is each of these trends, each of these approaches to artificial intelligence came from other sciences using similar types of argumentation for building new knowledge from other sciences. And therefore, the programs and the models that they've been using were inspired by successful models in the other areas. For us as psychometricians, the most common probably here is the Bayesian approach, which is really one of the ways in which a lot of our own systems and methodologies have been constructed and developed.
Alina, would this be, I'm sorry to interrupt you, but would this be an okay place to stop, or do we have, I can give you 1 or 2 more minutes to give Carol about 5.
Give me 1 more minute, thank you.
Okay, will do.
So I will skip this one and I will talk about computational psychometrics now, where I've been trying to bring all of these tools into our psychometrics framework, which is theory-based and psychometric-centered, meaning reliability, validity, fairness, generalizability. How do we do that is by looking at not only at the data from correct or incorrect responses as we used to do, but as all the presenters said today, by the fine-grained telemetry, by all this multimodal information that we have available, and coming back up to the models and the design that we started with. A very important insight for psychometrics, and it has been touched a bit about in this presentation, is especially against Stephen, is that content is data. So once we start thinking of taxonomy, standard, and knowledge maps as data, a lot of doors open for the analysis, including for generating text or for correcting scoring essays. And with that, I want to thank you all for attention.
Thank you so much, Alina. Fabulous. That's lovely. Carol, you have 5 minutes, so fabulous. Let's do that. Do you have anything to share, Carol, or do you just want to talk?
Yeah. Oh yeah. Okay. I'm just gonna share broadly because I've got 5 minutes. But
Great.
Thank you everyone so much for joining. And I just kind of wanted to think about for a minute back to that idea of the reliability and validity and fairness. And Piotr had brought up the idea of the varying definitions between machine learning and psychometrics. You'll also see just this from a lot of different interdisciplinary communities. Everyone has their own definitions. And he's also pointed out that there's a difference between looking at these and assessment and learning. So I just want to quickly break them down to the simplest possible form. I'm pretty sure this is probably what you'd see in a dictionary. I didn't just look it up, but reliability, it's consistency, right? It's consistency of what you're measuring. Validity, what is that doing? Measuring what you actually think you're measuring. Fairness, is it fair to various subpopulations? So it's funny to me is I think all of you are hitting those in their base component. Janice has a really strong emphasis on validity by incorporating learning sciences, and she didn't show her ontologies today, but she's had some very well mapped out ontologies back to practices, which is why I think she's getting those awesome results once she's giving help with practices on transfer to the next problem. Neil says he doesn't care about those in a tongue-in-cheek way. However, Neil has actually shown he gives the teachers what they ask for across the various books. He's measuring what he has intended to measure. And as far as reliability and really with validity on external studies from assessments, there was one from SRI, his results from student learning are highly correlated with improvements on state standardized tests. So those already have all those components that everybody wants to see. In regards to fairness, he has a paper on closing the achievement gap by using assessments. Maybe that's number of items. I think, Neil, you accidentally stumbled into all three of these and just accomplished them anyway. And I also want to say, as far as calling goes, how much I appreciate the work on the policy level. And I know you didn't have a chance to get through all of it, but that type of policy level is exactly what we need to try to get more global fairness and openness to the type of systems we have, especially during this time. So I will shut up because I know I only had a short amount of time, but thank you all. Go ahead, Andre.
Well, actually, no, this is wonderful. You have 2 more minutes. You actually do one person who has the least time but has extra time. Would you like to add and say anything else?
I think that it's important that we have conversations in interdisciplinary teams, because I think that there is a lot more of things that we will agree on than disagree once we get to base level definitions. When Piotr brought up that difference between psychometrics and machine learning, I've experienced a lot of that myself, realizing when we sit down and we work together, it might be a somewhat of a new methodology emerging on how we can blend in these base principles of psychometric to machine learning EM type world and how to get those together. And a lot of times it's kind of on the fly, but that type of teamwork is absolutely necessary. And I know Alina has done a lot of this as well. I don't think there's as many differences as we think. I think a lot of it is more in terminology and figuring out new ways to apply it with new types of data.
I see people ready to respond to what you just said, but in the interest of time for everybody, given that we have a large audience that we don't see currently, what I will do is I'll leave it on that optimistic note, and I will ask all the presenters to do everyone a small favor, including myself, is to send me the latest version of their slides so I can indeed create that zip folder. I want to reiterate to anyone who's on the call that if you want some information, write to me at dr.andre.rupp@gmail.com. And I want to finally say, I learned so much. It's always so wonderful to see everybody, and you're also fabulous. I wish you all the best in your work and in your endeavor. I'm so glad we're all colleagues in the same field, and now as we all blend together, it'll be one big super field very soon anyway. Thank you so much. I wish everybody who attended a wonderful day. I want to thank you for being with us today. And have a wonderful afternoon. Bye-bye.
Thank you.
Thank you.
Thank you, Andre.
Thank you.